Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. This is question 7 under May June 2022 question paper. So it says, how many years? This is our question. How many years will it take for an investment to double in value if it earns an interest rate? If it earns interest at a rate of 8.5 percent per annum, compounded quarterly. This is very important, compounded quarterly. So what I like to do when I do finance, I collect my data like this. I like saying for finance we have pain, like pain. All right. What is pain? P, it is the principal amount or the initial amount that you invest, right? Then A, it is the amount that you get back, right? What's the name of this? Oh, I've forgotten the value of A. But remember, it is if you A, it is the value that you get back after an investment or whatever the thing. Then I, it is the interest rate, right? Therefore, N, it is the number of years. So now, but the question says, how many years will it take for an investment to double in value? So we want the outcome to be double of whatever this P was. You get what I am trying to say? So an investment will double if we input 100 rand here. It means we want this to be 200, right? Or A, it is accumulated amount. Yes, accumulated value. So A, it will be double of whatever P was, right? Because we want this to double in value. If it earns an interest rate of 8.5% per annum, now interest rate, we want it in decimal, right? This is rate in percent, then I in decimal. So it's going to be 0, you know, how do you get I? You get I by saying rate divided by 100, right? So it's going to be 8.5 divided by 100. So it's going to be 0.084. But I prefer you to do this. Divide this I here, this I by the number of months that you compound your money or you invest your money. So here we are told that it is compounded quarterly. If you are compounded quarterly, it means now every 3 months from January to March you pay. Then from April, May to June. From July, August, September, July, August, September. Then October, November to December. So in a quarter, we have 3 months, right? So it means how many payments are you gonna do? For the first quarter, it is January to May. You make a first payment. All right, you're gonna pay at the end of March, you're gonna pay at the end of June, you're gonna pay at the end of September, you're gonna pay at the end of December. So it is 4, right? So you're gonna divide here by 4. Then the number of years is gonna be whatever the number of years multiply by this part quarterly also, which is 4. All right. So let me try to create space here. So here it is divided by 4. Then my n, it will be 4. This 4 here multiply by what? Multiply by whatever number of years that I do not know, right? Then now let's calculate. How many years will it take? Let's use our formula there. Our formula says A, it is equal to P into 1 plus I to the power of N. What is A? Accumulated amount. We want this amount to double from whatever the principal amount was, right? You can use any letter. You can use 2P from P, right? Then it's going to be 1 plus. What is our interest? It is 0.085. But I said you have to divide by whatever the compound and the months that you are gonna pay. Okay, so it is 4 in this case. So here we're gonna say 4 multiplied by n, right? Yes, 4 multiplied by n. So here when we do our math, it's gonna be, let's just divide by x by x. It's gonna be 2. It is equal to 1 plus. Let's leave this as it is. All right, say 0.085 divided by 4. Or rather, let's punch this, all of it, on our calculator and see how much it gives us. 1 plus 0.085 divided by 4. So it gives me something like 817 divided by 800 to the power of 4n. Now remember laws of how do I move from exponential to log? Remember, if I want to drop this, I'm gonna say, all right, it is 4n, but now I have to add a visa to it because it moves from one country to another, right? I'm gonna add a visa, which is log. Log what? This base remains the base. It means it's gonna be 817 divided by 800. Then now it's gonna be 2 here, right? Then n is gonna be, say, log of 817 divided by 800, then 2, right? Punch this on your calculator and say equal sign. Then that equal sign, do not write your answer here. Just divide that answer by 4. Then you get that it is 8.24, right? So they said what here? How many years will it take for an investment to double, blah blah blah. So you're gonna say n it is equal to 8.24 years, unless they told you to the nearest whole number, to the nearest years. To the nearest years is gonna be n it is equal to 8 years. To nearest years. All right, yes. So your answer there is this one. All right. Now, we move on and told that in this statement we are told that a company purchases machinery for 500,000. All right, this is us buying a stationery for school, 500,000. After 5 years, the machinery was sold for 180,000, and the new machinery was bought. Now, hear this story of mine. This is a scenario that we use in finance. I am a student at University of Pretoria, and I bought a laptop. Let's say I bought an HP laptop in 2024. In 2024, I bought an HP laptop that was worth 24,000. All right. Now, as the years pass by, let's say from 2024 to until I complete my degree in 2028. Now, if I wanted to sell this laptop, it will depreciate because the value will never be the same. Why? Because I've already used it and done what. So in 2028, when I sell this laptop, I might sell it with a less than even half of the total that I bought it with. Probably, maybe I'd say 8,000. I sell this laptop car 8,000. This what happens. All right, this what happens. But due to yes, this is what you're gonna sell your laptop with in that year. But due to inflation, the very same laptop. This is according to finance here. To this scenario, you should know it like this. But according to due to inflation, right? In 2028, the very same HP laptop that you bought in 2024 by 24,000, you're gonna buy it in 2028 by how much? By 31,000. This is according to inflation. This laptop here at the store, not at home. At home, if it is at home and you are using it, it depreciates. But if it is at the store, it does what? It inflates. All right. So if the store is selling the same brand after 5 years or 4 years, it's gonna inflate. But the buyer, you as the buyer wanting to sell this laptop, it's gonna depreciate. Those are the words that you should be familiar with. All right. Now let's move on to let's move on to question and ignore my story there off for a little bit. Calculate the rate of depreciation. Remember the rate, it is R, right? R, it is I multiplied by 100, whereas I, it is equal to R divided by 100, all right? So calculate the rate of depreciation of the old machinery over 5 years using reducing balance method. Reducing balance method, it is 8 is equal to P into 1 minus I to the power of n. Right? Remember, when something depreciates, its value it loses value, so we use minus. So let's go and do calculations. Let me erase this. Let's go and do calculations there. I just come here and change this positive sign to being what? To being minus instead. All right. Now, when dealing with depreciation, this value should be smaller than this one. This one should be bigger. This one should be small. Why? Because A, which is accumulated amount, is the amount that you are selling your laptop with, right? Remember, this is the principal amount, the initial amount of your laptop, and the initial amount of your laptop in this case was 500,000. All right. But after those years, 5 years, you sold it with how much? With 180,000. 180,000 here. So therefore, 1 minus what is our I? It is what we are looking for. It is what we are looking for. But this I, it was gonna be I divided by what? Let's see. All right, just leave it as I. Just leave it as I. Sorry. When you deal with inflation as well as depreciation, interest. Remember, inflation, it is the interest that they charge, sorry, for the goods and services that we buy, right? Those who are doing economics are very good with this chapter, inflation and depression. Yes. So for inflation, it is only applied once in a year. Once in a year. Once in a year. So it means it is compounded yearly. Also depreciation, it is compounded yearly. Right? So it means here I won't do any 5 multiplied by whatever. It's gonna be 5 multiplied by 1, which is in this case what? 5. And also this I, it is gonna be I multiplied by what? Compounded yearly, it is 1, because you pay that interest is applied once, right? So hence I leave it as I there. All right. Then when I solve mathematically here, I'm gonna have, when I divide by 500,000, it's gonna be 100 and 180,000 divided by 500,000, like this. This is 500,000. It is equal to 1 minus I to the power of 5. But these zeros will cancel, these zeros will cancel. So I'll be left with 18 divided by 50. All right. Then I'm gonna do what? I'm gonna take the fifth root on both sides. I'm gonna take the what? The fifth root. Then I'm gonna be left with 1 minus I, rather 1 minus I, it is equal to, what is the fifth root of this value? I'm gonna, instead of doing this, I'm gonna instead take this I to the other side. All right, let me show you exactly what I mean. I want to avoid rounding off, right? So what I'm gonna do, I'm gonna say, all right, I'm gonna take this I to the other side so that it becomes positive. It's gonna be I, it is equal to 1 minus, then I take this to the other side. All right, so it's gonna be 1 minus fifth root. Fifth root of what? Of 18 divided by 50. Then I get my IS. That, then I'm in a position of punching my calculator now. I'm in a position of punching my calculator. Shift. Then I say fifth root of 1 minus, or rather, fifth root of 18 divided by 15 by 50. It gives me this decimal, 0.1848, blah 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 blah, right? But remember, the question says calculate the rate. This is the rate, so I'm gonna multiply this by 100. Then I get my rate as, also here it is 48, rather 0. So when I get my rate to do this, to two decimal to two decimal, it is 18.48%. This is the answer being answered. I English is nice. But yes, this is your answer thereof, right? Now, a question 7.2.2. The rate of inflation for the cost of the new machinery is 6.3, right? Remember, this is depreciation value. This is depreciation value. So let's find inflation value. But the rate of inflation for the cost of the new machinery, it is 6.3% per annum. There is no per annum compounded monthly or what. It is per annum yearly, all right? Over the 5 years, over the 5 years, what will be what will the new machinery cost at the end of 5 years? So for inflation, we use this formula instead of minus. For depreciation, we use minus. For inflation, we use what? Plus. Now, remember I said for depreciation, your value here will decrease, and that's what happened. It decreased to sorry 280,000. But for inflation, this value here will increase. So let's prove using calculation. What is your principal amount? Your principal amount is 50,000, 500,000 rather. One, one plus what? One plus I. What is your I? You were told it is 6.3, but remember your I we want in terms of decimal. It is 6.3 divided by 100. So it's gonna be plus 0.06063. Then what are the number of years? It is 5 in this case. So A, it is gonna be equal to what? 500,000 into 1 plus 0.063 to the power of all raised to the power of 5. So as I've said, it's going to increase. It's going to be 678,635,11. Remember, this is man to this man, right? This is my inflation. Let me just put it here. Sorry, my inflation amount here. Inflation amount. It is how much? 678,500 or 635. 635, comma 11, right? Now let's move on to an interesting part of this finance in grade 12. Now we are told that the company set up a sinking fund, right, and made the first payment into this fund on the day the old machinery was bought. I'm going to analyze this. The last payment was made 3 months before the new machinery was purchased. Was made 3 months before. Let me reread this. The last payment was made 3 months before the new machinery was bought. Before or was purchased. Yeah, was purchased actually, not bought. Was purchased at the end of the 5 years. The interest earned on the sinking fund was 10.25% uh, PA compounded monthly. The money from the sinking fund and the 180,000 from the sale of the old machinery was used to pay for the. All right, hey, this English is too much. Let me explain your sinking fund so that you understand. So I repeat my scenario. Let me see. I have enough time for explanation. Enough time I have. Here's my car. All right. Here's my car. I buy this car in 2024. For how much? For 40,000, 400,000 actually. Let me make this realistic. All right. Now, this car, I use it for 5 years. After 5 years, which is 2029, the value of this car will depreciate. This car will depreciate, right? If it depreciates, let's say maybe it depreciates to 120,000. So it means I bought this car by 400,000, but when I want to sell it after 5 years, it's gonna cost 120,000. All right. But the very same car will inflate due to inflation, will inflate from 40,000 to an amount still 2029 to an amount of maybe 550,000. All right. So now, what exactly is sinking fund? Is me saying, all right, I wanted the same car, but a new one in 2029. But what will I do first? I will start by selling this car. I know, but selling this car, this old car of mine in 2029 will be how much? Will be 120. So it means I will have how much? 120 after selling the car, right? But I will need some amount. I will need some certain amount to add to so that I get to 550,000, right? So that amount, where am I gonna get that amount? So this is where sinking fund comes on. Sinking fund. This is where sinking fund comes on. Sinking fund is me saying, all right, in 2024, I realized, all right, this is 20. My car I bought is 400,000. So and when I sell it in 2029, it's gonna be 120,000. So I say, all right, I need to save money during these years, from 2024 to 2029. I need to save money, right? I need to save money such that when I sell this car by 120,000, I will have that the money that I saved from the bank and add it to the 120 that I sold my car with to get to this amount that I will get the new car with. All right. So how do I set my sinking fund? So I say my sinking fund, my sinking fund will be what? Uh, my sinking fund will be my inflation. What? Remember, sinking fund, it is the money that I need to save. So how much do I need to save? I need to know what was my inflation in that year, 2029, minus the value of my car in that particular year. Depreciate. Wait, wait. This English is running away. Depreciation, right? So I say, and sinking fund, you're gonna put FV because you are saving for the future. Remember, if you are saving for the future, we use future value, right? So, or just F for future value. What was my inflation in this year? In 5 years' time, is gonna be 678,635, comma 11, minus what will be my car worth in that 5 years? It will be worth 180,000. All right. Therefore, my F, which is my future value, which is my sinking fund, will be how much? Will be will be 498,000 rather 635, comma 11. This is my future value. This is the money that I need to save up for each and every month because we are compounding monthly, right? Let me come to another part. When I remember, you are going to Pep now. You are going to Pep. You are going to buy your iPhone at Pep. You are going to buy your iPhone at Pep. Now, when you buy that iPhone, remember they tell you that you're gonna pay for 6 months, or let's say for 12 months, right? You buy this. You buy your what? Your cell phone in January. But normally what happens is that the store will give you the phone in January, you'll have it, right? But you will start paying a you will start paying a month after. From February, that's when you'll start making payments of that car, that phone. All right. So normally, for a normal transaction, is that you buy a phone in January, in February you start making payment. If you start paying in January, it means you will have plus one extra month to the months that you're supposed to pay. So if you start in January, instead you'll pay for how much? For plus 1 month. All right. So it means you'll pay for 13 months when if you upapa and pay in January. So what happens is that when you buy your car now, you'll pay next month if you're compounded monthly that interest. But if maybe let's say um you buy your car now, in January, and your interest is compounded mm, quarterly. Quarterly. What will happen is that after every quarter, March, you make the first payment. Then after another quarter, which is June, you make a payment. Then after the first quarter, another quarter again, which is September, you make the first payment. But if you pay immediately from January, it means you will add these 2 months here. If you add in January, if you pay in January, it means the February and March part. It means you have added plus 3, because compounded quarterly it is divide. Oh yes, right. It means you have added another 3 months to your payment, because when all papa, instead of waiting for what, for March to pay, you decided to pay immediately. So immediate payment increases the number of payments. Let's tackle the question now without wasting any further time. I'm running against time. Now, what about late payments? If I pay, all right, if I pay and then end, let's say I was supposed to pay from March or from January to December, but I make fast payment and end up making payment from January to October. So I make my payments to be faster, meaning that I will pay, my last payment will be made 2 months before the actual month that I'm supposed to pay with. So it means I'm gonna, to my number of payment, if I'm supposed to pay for 12 months, but I make my payments to be fast such that I end in October, it means I have to minus the remainder of the what, the remainder of the months, which is how much from October, November, December. I have to subtract 2, which is the months that are gonna be left, which is 10. But what will happen? What will happen is that in that 2 months there, in that 2 months, the same amount, this amount that you have. All right, let's take the question. I think I'm running against time with explanation. Oh. All right. Now the last payment. So the first payment into this fund is made on the day of the old machinery was bought. So the company made immediate payment. So it means they will add extra month to their payment, extra month to their payment. All right, because they are compounded monthly, so they will add what, extra month, because they paid immediately where they were supposed to, whereas they were supposed to pay starting from the next month, right? The last payment was made 3 months before the new machinery was bought at the end of the was before the new machinery was purchased at the end of 5 years. So the payment was made 3 months earlier, so we're going to subtract 3. So in our number of payments, we're gonna say whatever the years, the number of payments that the original was supposed to be paid, plus 1 of the immediate, minus 3 of the what, minus 3 of the early payments done. So how do we find the number of years? Mhm. How do we find number of years? Uh, Allow me to continue this question in the next video. All right. So let's see in the next video.